So, hello everyone. My name is Siddharth Srivastava. My registration number is 21BCE5807. And today I'm going to show you Nand2Tetris Project and its simulation also. So, let's start. But before starting that, uh, I will show you the how to how to download this file. So, you have to go to Google and we have to type nand2tetris.org, and here is the first site here. You have to click here, and software you have to click here on the left side and click on this link. Zip file will open. So, and you have to extract that. So that's the only thing you have to do. So let's start. So it is my project on Nand2Tetris. So before moving further, let's discuss about basic computer architecture. And as we can see in the flowchart, it consists of input devices, output devices, and CPU. CPU also has further fragments like control unit, registers, and processor is also there. Combinational logic circuits are also there. So let's move further. So basic idea of Nand2Tetris we are going to discuss. So this is the flow chart, and as we can see here, there is, suppose we think of a idea, human thought, and we write a program, and abstraction is done using high level language, and compiler does that abstraction, and VM translator turns it into machine language. So, and assembler also further translates it for the computer to understand it, and it is also held supported by CPU, RAM, and chipset, and various other combinational circuits also. Let's move further. So one question may arise for us, that why are we using NAND gate? That is because NAND gate can be used to implement any Boolean function, and it is also called a universal gate. And this property is called functional completeness of this property of NAND gate. So let's move further. So now we will discuss what is Boolean algebra. So Boolean algebra is a branch of maths that deals with operations on logical values with binary variables. So the Boolean variables are represented as binary numbers to represent truths. So 1 is for true and 0 is for false. Elementary algebra deals with numerical operations, and Boolean algebra deals with logical operations. And this is the difference between elementary algebra and Boolean algebra. So let's move further. So we are going to discuss now what is HDL. HDL, it stands for Hardware Description Language. It is very much like a programming language such as C, and it is a textual description consisting of expressions, statements, and control structures. One important difference between most programming languages and HDL is that HDLs explicitly include the notion of time, and HDLs are also used to describe structure and behavior of electronic circuits, and most commonly digital logical circuits. HDLs are also used to simulate the circuit and check its response. Many HDLs are available nowadays, but most commonly used are like VHDL and Verilog. So now let's discuss various logic gates, and first logic gates is AND gate. The AND gate is a basic digital logic gate and that implements logical conjunction. So here we can see there are two inputs A and B and output is 1. Even if one output is 0, it will return 0. Otherwise, it will return true. So like 1 and 1 is shown here. So it means 1 and 1 will return true. Otherwise, it will return 0. So OR gate we will study now. So it is a digital logic gate that implements logical disjunction. So that means that even if one value is 1, it will return 1, otherwise it will return 0. So here it is now NOT gate. So it is the most basic gate and it is also known as logical inverter because whatever input we give, it inverts it. Like if we give 0, it will give 1, and if we give 1, the output will be 0. So now let's move further. Now comes the XOR gate. XOR gate is an abbreviation for exclusively OR. And if both inputs are same, it will return 0, otherwise it will return 1. And now let's study the multiplexer. Multiplexer is a device that selects between several analog or digital input signals and forwards the selected input to a single output line. This selection is directed by a separate set of digital inputs known as select lines. So in this multiplexer, this is a diagram, and I0, I1, I2, I3, these are the input lines, and S0, S1, these are the select lines, and there is one output. So, and it is a 2x1 multiplexer, like 2 inputs and 1 output. Now let's study about demultiplexer. So demultiplexer is a combinational circuit that performs reverse operation of multiplexer. It has single input n selection lines and maximum of 2 raised to power n outputs. So here we have 1:4 demultiplexer, like 1 input and 4 outputs. It is also based on value of selection lines. So now let's study the most important part, that is multi-bit versions. Multi-bit version is a very simple circuit constructed using M1-bit logic gates. So individual bits of M input value are each input into a different 1-bit gate that produces corresponding output bit of the M-bit result. So various multi-bit operations we have are AND, OR, XOR, NOT, MUX, DMUX, AND 16, NOT 16, OR 16, MUX 16, OR 8-way, MUX 4-way 16, MUX 8-way 16, DMUX 4-way, DMUX 8-way. So why only these 15 gates we are using? They are commonly used gates. And also they comprise of basic gates that are needed to build the computer. And further, they are classified into 3 categories: elementary logic gates, 16-bit variants, and multi-way variants. So it includes elementary includes NOT, AND, OR, XOR, MUX, DMUX. 16-bit includes NOT 16, AND 16, OR 16, MUX 16. Multi-way variants include OR 8-way, MUX 4-way 16, MUX 8-way 16, DMUX 4-way, DMUX 8-way. So now let's move to simulation part. And just a second. When we extracted the zip file, we will come across various options here. So here, like CPU emulator, assembler, jack compiler, text comparer. So we have to select hardware simulator. Okay, so I have already opened it, so I will open it directly. for you. So here it is. So now I will show you the various components in this hardware simulator. So this is load chip. This is single step run, like if you want to run code line by line. And this double arrows indicates it is used to run full code in a one go. And this is reset. This is load script. And this is used to adjust speed. Like we have to drag it too fast so that it executes well. And this is animation program flow. This is decimal. And this is view, like script mode, or we can we will see how it works. So let's start. So move on, click on the load chip on the left. So select here Nand2Tetris. Again, Nand2Tetris projects, you have to click. So these were the various projects that we uh, were included in the zip file. So let's click on 01. 1 second. So there are various options here present, and HDL and 16 demarks and all. So we will implement them one by one. So here is, let's click on and HDL. After clicking, click on load chip. After that, move on this right option where it shows load script. And here is TST file. So I forgot to tell, there are two types of file. One is HDL and other one is TST file. So when you're loading input, you have to click on HDL. You have to select HDL file, and when again we have clicking on this yellow button, we have to select TST file, and this is the important part which we need to remember. So load script, we have to do it again. So now let's run. So it has run successfully till the end of the code. So now let's see the truth table of this. If the truth table comes, it means it is correct. So yes, compare you here, it has truth table has come. So that means it is correct. So now let's do other option. Let's do OR function, or HDL. Let's select. So or TST we have to select here. And here we are running. It takes time sometimes to run because files are big. So let's do the compare option. And here is the truth value of OR. So that confirms that we are moving in the right direction. And now, or we have done, let's do not function. So here we have to select TST file. Here it is. So let's run it now. So now let's see that truth table. So here, yes, it is coming. Now let's try mux now. HDL file, and now TST file you have to select. It is taking time because it is a big file. So it has reached the end of the code. So here is the value of multiplexer. Now let's run demux. And demux TST. And now let's run. So now let's see its output. So yes, here it is. Here is the output. So now we have seen all the basic commands using hardware simulator. So we have successfully completed our project simulation. So I would like to thank you all to see my video, and in future also uh, we will implement various other projects using Nand2Tetris. So thank you.